Shruti Goyal from the team Tech Army. So, for the machine learning take home project, what we have done is implemented a full NLP pipeline that analyzes the stylistic and the semantic features of a Pushcart nominated poem and compares them with randomly selected or the scraped poem. So what we have done, we began by scraping poems from the web and then processing them using the POS tagging to compute the syntactic statistics. These statistics then we used to train a Pushcart poem classifier to base on the distance from a golden cluster, which we did using k-means. We also used constructs knowledge graph or the KGs for each poem to transform those into embeddings via sentence BERT and then store them in a stimulated vector database or the in-memory database, which we used as FAIIS. So we retrieved the related articles based on the poem content using cosine similarity and prepared LLM ready prompts to explain and expand upon the poetic themes and then evaluate the retrieval quality through structured team member experiment. Overall, what we have done is demonstrated that combining syntactic structure, semantic embeddings and retrieval from the external source can effectively rank, classify and help understand poems through NLP. So initially, we have installed libraries like Beautiful Soup, Request and Fake User Agent to be able to scrape the poems. Then we have a function called scrape poems that accepts a poem URL, title, author and source and sends a request using Beautiful Soup to scrape the poem. So I've scraped a whole list of 19 poems plus from 0 to 19, 20 poems. So as you can see that this is scrape poems. Let me show you the scrape poems, like how our complete list looks. So this is a list of all our poems, and then moving forward, so this is all scraping poems through Pushcart. Forward, what we have done is we have extracted part of speech counts from the poem using spaCy and then created vectors for each poem based on the frequency of part of speech tagging. We have used standard scalar and k-means with one cluster to compute a golden cluster of Pushcart poems. And the methods that we have used is that we have assessed a poem by its distance from the centroid, assigned a probability of it being like a Pushcart poem, and then bucketized it into a score of high, medium or low quality poem, as you can see here. So then we have applied a principal component analysis cluster, which we have used to reduce the POS features vectors into 2D space. You can see here. So the scatter plot is generated, as you can see here. Now we move on to the knowledge graph construction. So we have a function called poem to KG, which converts a poem into a dependency based knowledge graph using POS relation, which is like noun and verb head. The function we have applied to a sample poem to visualize the original graph and its transitive closure. The nodes here, they represent the keywords like the noun or the verbs, and the edges represent the syntactic relationships. So as you can see from the graph, the wind, the two, all these words are the nouns or the verbs, and the edges are the syntactic relationships. Then we have uh, then we have done what we have done is we have taken a new poem and processed into embedding using the same KG method. Then we have used the cosine similarity to retrieve the most semantically similar article from the vector DB, and the top three articles we have selected and formatted into the structured LLM prompt, which includes the poem, the summary of each retrieved article, and the instruction to LLM to analyze and synthesize them in the poem. So as you can see, here is the top three retrieved articles, and here we can see the LLM prompt which we have given right here. Sorry, my screen got stuck. So as you can see, this is the prompts that uh, these are the prompts that we have given, and the answer to the prompt that we have received from ChatGPT is right here. And finally, what we have done is we have stimulated three experiments from our three members. So I myself, Shruti, I have done tests using different chunk sizes of 20, 40 and 80 words for the embedding articles. And Man, he has performed tests using varying temperatures like 0.2, 0.5, 0.9 in LLM responses. And Siri, she has created tests using different poem queries and how well they have retrieved relevant articles. And then we have compared the scores of each of the three experiments. So overall, we have created a project to demonstrate a comprehensive machine learning and NLP pipeline that scrapes and processes poems, analyzes them syntactically using POS tag distributions, and builds statistical and graph-based modules to define quality in poetic language, and retrieves the aligned reference material, prepares LLM to enrich and explain the poetic themes, and ultimately compare the scores of the retrieved poem with the random poem. I hope you liked our project. Thank you so much.